All right, hopefully this is going to work. Wi-Fi is out yet again. So last time we were working on building this book structure. In fact, a series of structures here to model a book data structure. Remember that our conventions here are, at least the modern conventions, are to use upper camel casing for the name. So for example, book, person, and date are all uppercase, the first letter. If it was multiple words, then it would be, camel cased, and each word would be uppercased after that. Generally, the structure declarations are placed in header files. So for example, I'm going to have to create another file here, but let's go ahead and create a new file since I don't have access to my CS50 IDE here. Create book. There we go. There. Now that structure definition is in the header file. And over here in the source file, of course, we include that. Include book.h. There we go. And I'm also doing a bunch of other stuff in here, so I'm going to start including the standard libraries. stdlib. I'm doing some input-output stuff. No, I'm doing some string stuff, excuse me. String.h. There we go. All right. So there's my book data structure. There is my book creation function, right? And last time I said there might be an issue here with memory leaks, right? There might be an issue with memory setup, and we're going to take care of that today. Unfortunately, I'm not going to be able to show it to you. Hopefully this still works. I set this up before I came here. But what I want to do is I want to show you a basic call to that create function. So this create function is passing in, say, the title, the first name, last name of the author, the year, and the rating here. And then we assign that a value. We assign that to a local variable here. Now, note what I've done here. I'm not going to recompile this because it won't work because I'm not online here. But this is a regular old variable, right? What does create book return, though? It returns a pointer, right? So let's watch the execution of this. Hopefully it still works. But let's watch the execution of this as it goes through this program, right? So first of all, we call, let's go all the way to the beginning there and then go next. Oh, no, it's jumping all the way to the end. All right, well, in any case, I can still show you what it is. How many books do you actually see here? In other words, how many big boxes containing all the data for a book do you see here? In the main, we've got this local variable called b, right? That's where this is right here, right? But then when I call this function, I create a brand new book here, and that's what that pointer is pointing to. Down here, where is it? In the function, in the heap here, I've got a pointer. There it is. There's the pointer to book B. That's in the actual function. So I've got this copy right here in the main, and then I've got this copy down here in the actual function. What's going to happen when I go to the next here? Right? All the stuff has been copied over. The title of the book, the first author, author's first name, author's last name, the year, month, and date. Well, actually, we just did the year and the rating right here, right? Let me go back one and ask you, what happened to this thing right here? Well, it returned from the function, so did it get popped off the top of the stack frame? If it were on the stack, yeah. But guess where it is? In the heap. This is a memory leak right here. Right? In fact, let me go ahead and create a new tester here. New book demo.c, let's say. Int main. I'll keep it simple here, although I probably want to zoom in. There we go. Let's go ahead and include book.h. I'll probably want to include everything else as well. Oh, there it is. Just take that stuff. All right. Oops, put it at the top. I'll worry about spacing later on here. But let's go ahead and create that book. I just want to steal that code because I already wrote it. Copy that, put it over here, book. There we go. All right, so if I were to run this through Valgrind, and unfortunately I don't have Valgrind installed on my computer, but you could, it'll report that there's a memory leak. Let's follow along line by line here instead of the visualization. So we call create book. In create book, we allocate a brand new book. So we've got now two B's, one in the main and one right here being pointed to. Ultimately, what we do is we return that pointer. But at this line, everything gets copied over into this book. What happens to the original one that the pointer was pointing to? It gets lost. Okay? So how do we go about fixing this? One way that we can fix this is by redesigning or adding to this create function right here. This create function, and let me document it here. Actually, no, we'll document it in the header file here. Right? What does it do? It creates a brand new instance of a book with the values passed in, and returns a pointer to it in memory. Okay. Well, what if we already had one created? In other words, that's what we have right here. Ignore that piece of code right there. That is a local variable. We didn't have to call malloc on it. It's just a regular old variable. Just like we would say int x. That's a regular old variable that has 4 bytes in memory. It's already been created for us. You can go ahead and set that equal to 42 if you want to. Right? I've created this book here that already exists in memory. I don't need to call malloc. So what I'm going to do is I'm going to design a different function. A function that does something very similar to this, but in a different way. I'm going to call it, oops, here, let's go ahead and cut and paste it like that. And I'm going to call it, instead of create book, I'm going to call it init book, void init. Init is going to be short for initialize or initialization, okay? And let me document this and how it's going to work. Right? This function initializes the given book with the values passed in. Right? In other words, we're not going to create a brand new book and return a pointer to it. Instead, we're going to require you to give me a book that has already been allocated in memory, and then I will go through and set all 5 of those elements. Right? That means that we need to change the parameters here. What I'm going to do is I'm going to pass in a book by reference. Right? Oops, comma. Right? And then slide everything over there. Right? This is now also part of the input. That book has already been allocated. It's a pointer to it. It's over there in memory right now. Right? I'm going to go ahead and initialize the title, the author's first name, last name, publish year, etc., etc., etc. Right? That's a very subtle difference, but a very important one in order to avoid having these kind of very subtle memory leaks. Okay? Let's actually implement it and see what it will look like. Let's go down here. There we go. All right. So we're already given the book, B. We don't need to create it. In other words, we don't need to do this line right here. It's already been created for us outside the function. We've been given this pointer variable right now. Right? All we have to do are these lines of code. So let me move those or copy those and move them down here. Come on. There. Right. Now what am I returning? Return what? Well, what's the return type? Nothing. So just return. Right? One advantage to this is, even though I have it as a void function right now, I could change this into an int function and return an error code. You gave me a title that doesn't exist, like a null title. Or you didn't specify the author's first name. I'll go ahead and return a null pointer or return an error code or something. I'm going to leave it as a void function for now. Right? That's the only difference. Does the book already exist and you need to create it? Or it already exists, you give it to me, and I will go ahead and initialize everything. Before we look at how to use this, that should be a huge red flag right there. Right? That code was copy-pasted and put down here. Do we have a better solution? Don't repeat yourself. DRY principle, don't repeat yourself. Right? That code is repeated there and there. One of these functions should be calling the other function. Right? The more specific function should be calling the more general function. Which one of these is more general in the following sense? It does more. So does this function do more, or does this function do more? This one does more because it does one thing more. It actually initializes the book. So this function will end up calling this function instead. How? Just by simply calling init book B, right? Title author, what is it? First name, author, last name, and publish year. And rating. There we go. Right. There. Now there is no repeated code. You set up the memory for the book, you initialize all the aspects of the book, and then you return the book. This one assumes that the book has already been created. Given these pieces of information, it sets up that book and then returns. By the way, I've made all these things const. Why didn't I make book be const? I'm making changes, aren't I? I am making changes to the title. I'm making changes to the author's first name, etc., etc., etc. So you can't make it const in that case. All right. That all looks good. That book demo looks good. Now let's look and see how we could use this instead of returning a pointer, dereferencing that pointer like I do right here, and then having a memory leak. What I'm going to do is I'm going to call that init function instead. All right. So this is bad. I'll leave this bad memory leak right there. All right. So let's do it differently. Book B. Right. It already exists. It already is allocated in memory because it's a local variable like this. So I can now call init book on something, and then the rest of that stuff. All right. There. All right. Beloved children's series by Brian Jacques. Right. So init book. What do I pass in for the first argument? The book itself, right? Is that correct? Well, book is a regular old structure. It's a regular old variable. What does init book expect? A pointer. How do I change a regular old variable, say an int x, into a pointer so that it can be passed by reference? Ampersand. There we go. And then I can print it out. I don't have my print function. Do I have my print function anywhere? No, I don't, unfortunately. So, but we can go do this printf title is equal to %s and the line, and then b dot title. Or is it, or b arrow title? Which one is it in this case? Dot, why? What is b? B is a regular old structure. Regular old structure, direct component selection operator, dot. There. Right. And now I'm going to have to open up a terminal here. Just a second, bear with me. Desktop, temp. Right. Thought they had it fixed on Friday. It worked perfectly on Friday, and then I'm going to have to ream them again. GCC, demo, C, book. Actually, let's walk through this because we've been seeing an inordinate number of people not knowing how to compile from, say, module 6. So I've got these files here, book.c, which is a library, and then I've got my main tester here, my main driver programmer over here. How should I go about compiling this stuff? I need to compile this library first. So how do I compile that? What flag do I use to compile that? Well, let's just try it like this, book.c, right? Is that going to work? Well, once it gets loaded up. It's going to say something about undefined reference to main. Do you see a main over here in book.c? I don't, right? A main is required in order to create a executable program, a.out. We don't want to compile this into an executable program because it's not an executable program. It is a library of functions, like mymath.c or whatever we did, financialutils.c. Right? How do I compile it? What flag do I give it? -c. What will that do? That produces a book.o file. Right? That's an object file. Now I can produce an executable file by going gcc book.o and bookdemo.c. Right? And I can run it. There, title. The rest of this stuff. Okay. All right. What else should I have done, just as a review here? What else should I have done the entire way, the entire process of compiling? What else should I put in there to make sure that everything was good? Wall flag, if you want to get really pedantic, extra. And if you want to run Valgrind, which unfortunately I don't have here, but we can move this over to CSE if we want, and then I'll have Valgrind there. What else do I want to put in there if I want to debug it or run Valgrind? G, right? And likewise with this, wall flag, wall extra, and G. Right? Oh, good. Warning, variable X is set but not used, right? That was just me showing you a regular old variable, right? Let's go ahead and get rid of that. Right? All right, so GCC, and that should go away. Right? No warnings. Does that mean it works? Does that mean it works? Not necessarily, right? I should be running valgrind to determine whether or not it actually works. Okay, if we want to, we can do that. Just as a reminder for how to do this, cd desktop. Nope. scpr. I've got everything into desktop temp, into my cse.unl.edu. Oh, duh. No Wi-Fi. I can't go to CSE. It's funny how everything depends on Wi-Fi, right? Everything depends on it. It's so dependent that you just do it without thinking about it. Do I have it over here? Yeah, but there's no way to transfer the live stream over there, or the recording at least. Right. Sorry. Right. So, one other thing. If I had run valgrind here, I would still be getting memory leaks. Right? Not this memory leak anymore, because there's no duplicate. What would have happened is this would have been passed by reference, and all these values would have been immediately copied into first name, last name, and the rest of it. Right? But there's still a memory leak here in the main, if you want to consider it that way. Right? For example, what if I created another book here? Book B2, for lack of a better variable name. And I will go ahead and call create book on similar but different. Let's change this to Redwall. Right? Brian Jacques, I don't know, 1985 maybe. Right? And we'll just say that it's much better than that one. Right? So if I just exit, right? If I just end right now, return 0. What about, and it's not that big of a deal in main. Memory leaks don't matter in main that much, at least for this course. Have I cleaned up this book? Nope. So let's do that. Free B2. Except that, let's look at the memory of this thing, right? That means that I would be cleaning this box up right here, right? Tell me about that box, though. That box has references to other boxes that have strings. In this case, the title, the first name, and the last name. If I just free up the book right here, what happens to those things? This box will get cleaned up right here. Great. What about these 3 boxes down here? They're going to be left out, and we've got, what is that called now? When we fail to clean up memory, but then lose all access to it, so we can't clean it up? A memory leak, right? You detected memory leaks in a lab 7, and then you fixed those. Right? Let's fix it now. I can't just free up B2. Right? I have to free up everything that B2 is pointing to. That's going to be what? Over here. Right? There we go. So a book, right there. A book is referring to a title. That's got to be cleaned up. So let's free up that first. Free B2 dot or arrow title. You tell me. Arrow, why? Because we've got a pointer to it. Pointer to a structure means that you use the arrow syntax. Right? What else do we need to free up? There's the title. Right? What else do we need to free up? The author's first name and the author's last name. So let's do that next. Free B2 arrow author dot first name. Now remind me, why am I using the dot operator here? B2 is a pointer to a variable, but what about author? Yeah, it's just a person. Is it a person star? Nope. It's just a regular old structure. By the way, we could have designed it like that. In fact, in real life, if this were a real application, I probably would. I would make pointers to everything to make sure that I don't have regular old variables like that. Right? All right, but I'm using the dot operator here. First name and then last name. Man, that seems so complex. What if I wanted to do that over and over and over again? 1, 2, 3, 4 lines of code. What is that kind of telling you that you should do? Make a function. Let's do it. So this is a factory function. It creates things. Right? It creates new instances of a book. Right? It prints new books. This one is, it initializes it. So you've got an empty book with no pages written yet, and then it stamps the text on it. Right? It actually initializes that book. Now we need to do the opposite. Void free book. Right? That takes a book by reference. Right? By the way, could I make a const in front of here? Am I going to be making changes to book? Yeah, I'm going to be destroying it. Right? I'm going to be freeing it up. So, can't make it const. There's that function. And take that code, move it here, and you're good. Could I call it free? Just free B2? No, because that's already been taken as a name. Free book. There we go. Oh, and then I think I screwed up. Yeah, not B2. B2, oops. B2 and B2. There we go. All right. And then return. Throughout this entire process, I was doing no error handling whatsoever. Let's go back and consider that. I won't do it all because I trust that we're now at a point where you can do error handling. But what could go wrong, say, with create book? Pointers be null. So if title is equal to null, or author first name is equal to null, or author last name is equal to null, oh, or publish year equals to null. Does that make any sense? Can publish year be null? It's not a pointer. Right? That doesn't make any sense. Okay, so let's go ahead and get rid of all that. What's the only thing I can do in this case? Should I do the following? fprintf into the standard error. Can't help you, man. Sorry. ... And then exit out of the entire program. Should I be doing either one of those things? And again, I'm doing this as a review because I've been seeing this all over the place. Right? These are the two things you explicitly never do in a function. Right? You never exit, right? If you call square root on -2, does it exit out of the program? No. If you call square root out on -2, does it say, you can't do that, that's bad math, right? No. Right? What does it do? It sets an error code somewhere. What can we do here? All we can do is return. Return 1? Yeah, why? Oh, what does returning 1 here do? It returns the memory address 1, telling you, yeah, your book is over there in memory address 1. Go ahead and check it out. Right? Does that memory address even exist? Unlikely. Right? So, what do I return? What's the only thing that I can return when you're returning a pointer upon an error? Null. Right? Anything else could go wrong? Yeah, weird publish year, right? Else if publish year is less than or equal to 0, right? Because there was no year 0, right? Year 1. Right? Okay, yeah, I can get that, right? Or publish year, if you want to go the extra mile there, is greater than or equal to or greater than 2023. Should you ever hard code to something like that, though? Now, your program will be obsolete in 2 months, right? So I'm going to leave that out, right? Okay, that's sensible. What about the rating? By the way, this is a goodreads.com rating, which is on the scale of 0 to 5. So you could check that. If the rating is less than 0, right, it's possible to have a 0 rating, terrible book or unrated book. Or the rating is greater than 5. Then return 1 in that case? Nope, you can't make any distinction there. It's always going to be null. Right? What about this one? Same basic stuff, except for what? What would you do in that case? Everything else could still go wrong, but maybe something else goes wrong too. What? Yeah, book is now null. So let's check for that too. B is equal to null, or the rest of the stuff, or whatever. Can I return null when the return type is void? No. Do I return 0? Return type's not an integer. What do? You just return. Right? This is sometimes referred to as a no-op or a noop, right? Equals no operation, right? You don't do anything. Right? Noop. All right. What could go wrong here? B could be null. These could be null. Check them out. Again, I trust everyone can do this at this point. Right? All right, so to sum everything up, let's see. Once defined, you can declare a structure like any other. To access member variables or components directly, use the dot operator. When you have a pointer to a structure, you use the arrow operator. Right? So for example, if I've got book star B is equal to whatever, 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 then to access its elements, B arrow title, right, is equal to whatever, whatever, whatever. Right? So pointer, use an arrow. Regular old structure, use a dot. Right? We defined factory functions. You can define factory functions to create new instances of your structure, returning a pointer to a dynamically allocated instance of the structure. Remember, how did we do that? To use size of, right? Whatever your structure is, size of book, size of author, size of person, size of date, right? And malloc, with malloc. Right? And you only want one of them. Remember how I did that up here? Let's see, where is it? There it is, right? I wanted malloc, I wanted one book, and I explicitly multiplied this by 1. I did that. I mean, you don't need to do that, right? X times 1 is X. So you could simplify it. I'm doing it simply to drive home the point that I am creating one book. Right? I'm making my code clearer and more intentional by doing that. Right? What else? You have the dot operator. Other common functions, right? A toString function that returns a string that is a char star, a representation of the object or of the structure. Right? We did that. A destructor function that cleans up all memory associated with a structure. Right? Free book. We made sure to destroy all of the stuff, and this is sometimes referred to as a destructor. Okay. You can also have an initialization function, and the use case there is if you already have a structure in memory, it's already been allocated, then you just need to initialize each one of those things. Okay. And then similar functions that act on an array of structures. Right? For example. What about print all books? Right? And we'll come up with a better name here in a second. What if I wanted to print all the books? Okay. Well, what did that print book function look like? And unfortunately, we've lost it because we haven't lost it, but I'll post it later when I finally have internet access here. But we actually had two functions, if you remember. We had a char star book toString function that took a const book star b, right, and returned a string representation of it. And then we also had this void function called printBook that took a const book star b and simply printed it to the standard output. Okay. What would a function that prints all of the books look like? So print all of the books. Is that a good function name, first of all? Probably not. Let's shorten that up. Could I use print book? No, I've already got that, right? And besides, I want to print 5 of them. I wanted to print an array of books. Right? So what should I call it? Exactly, print books, right? And we'll make that into a void function as well. So I need to take an array of books. If this were an array of integers, what would it look like? Like that. It's not an array of integers. It's an array of books. So what should it look like? Book. Right? And I'm not going to be making changes to it, so let's go ahead and put const in front of it. Right? I don't want to call it ARR because what is it? So you could call it library if you want to. Otherwise, let's call it just books. Right? Now, how many books was I passing to print book? 1. How many books am I passing to print books? Yeah, so we need another variable. Anytime you pass an array of something, what else do you need to pass? The size of it, n. Right? So let's document what this is going to do. Prints each of the books to in the array books to the standard output. Right? And there are n of them in there. Okay, so this is what gets me here. This is a pointer to a book array. This is a pointer to a book array. Right? Yes, on both of those accounts. It's a pointer to something. This is a pointer to a book, and the lack of the another thing telling us that there are multiple books implies that there's only one. It's a pointer to one book. This is a pointer to how many books? Say 5, right? It's an array that contains 5 books. The additional parameter here is giving us the hint that this is an array. Right? There are n of them. N is equal to 5, say. In other words, you pass one book by reference using a pointer. You pass many books by reference using a pointer in the same exact way. How do you know that one is one book and another is an entire array of books? Well, it's in the name of the function, it's in the documentation, and it's in this second parameter here. If you didn't have that parameter, would I be able to tell you how many books I'm actually going to print? Nope, there's no way. Right? So we're going to print that many books. Let's do it. All right, don't reinvent the wheel. I don't have it here, but suppose that I actually had the code to print the book. In fact, we can write that really quick if you want to. We'll just rewrite it. I'm not going to use my toString function, so let's just do it directly. Printf %s by %s comma %s released in %d year, end the line. Right. So this is b title. Why am I using an arrow operator there? I've got a pointer to a book. B's author dot last name, b author dot first name, and then b publish date dot year. Is that right? Let's check. Publish date and then date dot year. Good. We're good. All right. So don't reinvent the wheel. What would you do to print each and every single one of those books? A for loop? Okay. Why'd you go with a for loop? You know exactly how many are there. Right? I starting at 0, I is less than n, I plus plus. An idiomatic for loop here. If you wanted to, this would be num books, and it's even more expressive, but n is good enough. Right? Now what? Yeah. Copy paste. Copy paste this. Nope. Copy paste this line, sorry. Nope. Do what? Call your function. Print book. And how do I get the ith book? Books sub I. Right. Let's find out if this works. By the way, if you want to make it pretty, you can print a header here. Printf, title, and then, I don't know, tab over or whatever, author, and then year. Right? There we go. And then if you want to get real fancy, you can get into ASCII art, printf. Oops. Put that into there. And then make it real nice. Right? Something like that. Right. There. Right? A header and then tabular form here. You can print it out afterwards if you really want to, too, just to keep everything nice. If you want to print vertical lines, right, you can get real fancy if you really want to. Let me go ahead and try to compile this stuff. Right? So GCC, let's just compile the book library for now. Right? Okay. There's something wrong on this print book line. Let's think real hard about this. Okay? I'm going to map this out. What is books? Is a pointer to an array of books, right? It is a book star. So when I go books of I is a ... You tell me. Just one of them. Is it a pointer anymore? Nope. That's an actual book. Is a single book. In other words, a regular old book. But print book expects a pointer to a book. In other words, a book star. Right? Right there. So how do I take this regular old variable and change it into a pointer variable so that I can pass it over to that print function? We need to translate, I don't know, translate books sub I into a pointer in order to pass it to print book, excuse me, ... To do that, I heard the answer out there. What was it? Ampersand, book sub I. Right? There. Right. And now this will actually compile. Or it should. It's complaining about printf, fine. Where is printf located? Standard input output library. There. Okay. Let's GCC everything together. Of course, I'm not using it, but let's do it. Let's use it now. All right, let's come back over here. Okay. Let's create an array of books. My library. Book. I'll just call it my books. I'll create 3 of them. All right. Now, does that actually create the books? Nope. I now need to create those 3 books. We'll go with, I don't know. All right, you tell me your favorite books. You're going to have to look these up for the year, or we're going to have to make them up or something. Right? My books, sub 0, right? Should I be calling create book, or should I use init book? Or init book. Remember what the difference was. This creates it. Right? It dynamically allocates it for you and then gives you a pointer to some other location. This one assumes that you already have it created in memory. Which one is most appropriate for my books of 0? Init. Why? Because it already exists. These 3 books already exist in memory. They just haven't been set yet. So let's init book my books sub 0. All right. Give me your favorite book or the book that you're reading right now. Anybody? All right. Oh, that's way too long. 3 body problem. There we go. By Xizin Liu. Somebody look up the spelling of that. I don't know. I'm going to estimate 2005 maybe, right? And there's no H. Okay. Season. 2000 what? 8. Oh, okay. I wasn't that far off. I'm giving it a 5. Right? Init book. My books. All right. I started it. You go ahead and give me another one. Say what? Art of War by Sun Tzu. Give me the spelling. Like that? TZU. All right. I don't know if there's a transliteration of that stuff anyway. I don't know. 1500? You tell me. 1200? I'm just going to estimate that.
Somewhere in it was translated into French in 1772.
Okay. 17.
5th century BC.
All right, so negative 500. There we go. Except that we already said that year is not available. So I'm just going to go ahead and put, I don't know, 1. There we go. Year 1. Give me another book that's not so complicated. Good Omens. Okay. No, that's complicated because there are 2 authors. All right, we'll just put Terry Pratchett. There we go. 2 T's, I think, right? That'd be 1990 or so, thereabouts. I'm not sure. And we'll give that one a 5 too. Definitely. Right. Now, remember, same argument as before that we had over here, right? That books of I is a single book. Print book, or init book in this case, expects a pointer to it. We need to translate each one of those into a pointer in order for it to pass over to init book. What should I do in front of each one of these? Ampersand, ampersand, ampersand. Now, let's see if it all works. Print books, my books 3. Okay. GCC everything together. And let's see if we get that outcome. 3-body problem, Art of War, Good Omens. That all looks like the data we gave it. Now, when you're doing your own data, you can make up whatever you want, right? All that you're looking for is, did the data that I put in my test case actually make it out onto the screen like this? All right. So you have a lot of different ways of handling data here. You have ways of handling one piece of data. You have ways of handling multiple pieces of data. If you really want to get into it, you can go ahead and watch video 11.3. In that video, what we do is we look at, well, what would it look like if instead of a contiguous array of structures, what if you had an array of pointers to structures? And there are 3 ways that you can do that. I go through each one of those 3 ways. I'm not going to do that in class because I don't want to confuse you. If you want to go the extra mile and look and see what those look like, great, go ahead and do it. But we're only going to be looking at the very simple usage for arrays as we've done so far. Okay. There's like the way that I do it is I present it as each one of those is a pointer to somewhere else completely different in memory. Then I go through a hybrid approach where everything, we've got an array of pointers, and then we've got an array of contiguous elements, and then those pointers point to each one. The advantage there is if you were doing data-intensive stuff, if you wanted to, say, sort it, then you don't want to take this chunk of memory and this chunk of memory and swap them. Instead, you just want to take this pointer and swap those. It's only 8 bytes that you're changing instead of 50 bytes, or if it's an entire book or something like that, then megabytes of data. Swapping that can be expensive. Right? So again, if you're interested, look at video 11.3, but we're not going to expect that at all. Right? It gets real fancy really, really quick. Right? All right. Any questions? Then for next time, if we either do a review next time, or I'm going to give you the following challenge. Print a countdown. Right? Write code, of course. Write code to print a countdown. That is 10, 9, 8, 7, 6, ... 1, and then blast off. Right. But you may not hard code anything. And even more importantly, you may not use any loops. No for loops, no while loops, no do while loops if you took do while loops, if you ever took a look at any of those. Right? Can you do it? So we're going to do it next time, but before we leave, tell me, what do we have at our disposal then? We can't hard code anything, right? We will be using printf. We have to. We don't have any loops though. What else do we have? Well, we have user input, okay. So that might be a tool. We have, what else have we looked at? Well, we've got malloc and we've got arrays and stuff like that. Yeah, okay. But you'd have to write a loop to iterate over that array, right? So we have conditionals, right? Well, yeah, okay. Conditionals to be able to determine if you should print out a number or these words here, right? But what else do we have? We have enumerations, but those don't change, right? They're static. There's a list, right? And even then, we would want to iterate over that list. All that I see that we have left is functions. So how could I use a function to do this, right? Nope, you're not allowed to use loops in the functions. You're just allowed to use the functions. And by the way, if you think that this challenge is artificial, it is not. There are languages that either discourage you from using loops or do not have loops at all as the control structures. Right? Instead, the next module, if you've looked ahead, is recursion. Right? So how can you use a function that calls itself to get this kind of behavior here? This 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 blast off. Right? Yeah, so think about that for next time. Hopefully the live stream will be working again. Right?